Okay, so we are live once again, and let's try to solve the next task. So I'm sharing my screen. And let's go to our neetcode roadmap. And we are on binary search, and the next task would be time-based key value store. Let's check. So time-based key value store, we have to design key value data structure that can store multiple values for the same key at different timestamps and retrieve the key's value at certain time. So we have our class that we have to implement. And we have two methods. So set method with unique key value and timestamp. So we have to store the key with the value at the given timestamp. And we have like key and timestamp. And we have to return a value such that set was called previously with timestamp prev. Yes, this one I'm not sure that I understand. Okay, returns a value such that set was called previously. Set method. Okay, with timestamp prev is less than timestamp. Okay, if there are multiple such values, it returns the value associated with the largest timestamp prev. If there are no values, it returns an empty. Yeah, so not sure that I actually understand how this get should work, especially with this condition, but let's try to take a look at the example. Okay, so in the example, they create a data structure, they put foo and value bar with timestamp 1. Okay, and then we get foo timestamp 1, we return this bar, and we get foo by timestamp 3, and we also return bar since there is no value corresponded to foo at timestamp 3 and timestamp 2. Then the only value is at timestamp 1 is bar. Okay, so we have to have some data structure that is sorted by timestamp. Okay. Then we set another foo with bar 2. Okay. And timestamp 4. Okay. Then we get bar 2 and bar 2 with timestamp 4 because it's actually the greater timestamp for us. All right. I think that I understand. So let's think about data structures that we can use. So if we are using a map, for sure our key would be our string that we are getting. And then we should get some data structure that is sorted by timestamp. And in this case, we can use tree set, for example. And with tree set, we actually can get a comparator of timestamp. And yeah, because we can also like have an array inserted every time when we are setting the value. But I think in this case it would be, yeah, I think it's with time complexity it should be the same, because with tree set we also should to reshuffle it. Okay, so let's think. What should we also use here? We can like set in this value, and when we try to get, then we check if it exists with a yeah, so we can have like two maps here, and here it would be timestamp and value, and we can actually check. Yeah, we can get like by map, and then we have another map with this timestamp, and we can check like if it's not exist, then we just yeah, we get set of these values, we can sort it, and then just go one by one from sorted set. Yep, let's try to do this one. All right, so we have our private map with string as a key, and another main map with integer timestamp and string as a value. So it will be our map. And we would like initialize it here for simplicity. So with set, it's very simple. So we get, we check if it exists. So if map contains key. So if it contains, then we just map get by key our another map, timestamp map. And yeah, and here we can actually just put yeah, we can just put into our map this timestamp and value. Otherwise, if it doesn't, if we don't have such key, we create new hash map. Timestamp hash map. We also put it here. And yeah, and we put as well by our key our timestamp map. Okay, so that's actually all our set method, and then in get method. So we are checking if we try to get something but we don't have it, then if our map get key equal to null, we just return an empty string. If not, then we just get this by key. It would be our timestamp map. Okay. And now what should we do? Yeah, what should we do? We should sort. So we can take a set. It would be our set of integer. can sort this set. I think collections sort. It would sort our set. And then we can just go by value. Yeah, I think we can do even better. We can make it as a list. Because I don't think that set actually sort. Yeah, so we have collection sort this list. So we sorted this list. And then we go just by list. From the back direction. So we should go from yi list length -1, I is greater or equals to 0. And I minus. Okay. Here should be size. So here we get list get I. It would be our integer timestamp. And we can check if timestamp. So here, for example, we have 5. So we should return something that is equal or less, right? Something that is equal or less. So if our timestamp is greater or less than this timestamp, we just return this from this map get timestamp. Otherwise, we return an empty. Okay, let's run it and check. Okay, and submit. Okay, so we have time limit exceeded. It's probably because of this sorting. And yeah, and that's because we have big number of elements. So how can we do it better? Time limit with get set. Okay. Okay, so yeah, I think that we can do it in set, actually not sort, but use some tree set, as I told. And yeah, it would be much better. Or we can also improve this one. For example, we can just check if get this timestamp not equal to null. We just return timestamp get. Yeah, so we can improve this logic a little bit. but I think it still will be timeout. Yeah. Okay. Let's try to use here a tree map. So it would be tree map. Here it would be tree map. Yeah, I don't remember how initialize tree map. Let's check. Okay. So with tree map, I think it would be sorted by default. So we don't need to sort it actually. I believe. So we have this tree map, and we don't need this list. I think we can just go through our tree map, how to iterate over tree map. Okay, so we have entry, iterate backwards. Descend and set. Oh, okay. Let's try this tree map descend and set, how it would work. So we iterate over descend and set. Here we have a key, and yeah, so we can get by key. Instead of list, we can get by key timestamp and return it actually. Well, let's try to run. Line 12, tree map. Here we need tree map. Here we need tree map. Yeah. Descendant key. Descendant key set. Okay. So what? Here. Yeah, so map key. Okay. Yes. String cannot be converted to int. So it's actually value, right? So we can do like this. And let's submit. Okay, so with stream-map, we see that it works actually, because it's slightly more optimized, because it would be not sorted every time, and only in case it would be like reorganized red black tree. Let's check what is more optimal here. Okay, map array list. If map contains, we put timed value timestamp. Okay. And how it get works. So we get from map our array list, and we have pointers. We find our mid. Okay, so they use actually binary search here, and I didn't use binary search. Yeah, so they try to use binary search, but I mean, how do they know? How do they know that these values are sorted actually? So because we have like just array list here, some timed value, we just create new array list. If it's empty, add. Then if map contains key, we go here, we get this list values. Okay. 1, 2, 4, 5, 3, left, right. Mid value. Timestamp. Let me check solutions. We use hash map to look up ordered pairs. Then we use binary search to find the value with a timestamp less or equal to the requested one. Yeah, but here they have like two map. Insert, but how does it get like upper bound? Since our timestamp are only increasing. Okay, so if it's only increasing, then it makes sense, because I thought that it can be in different directions. Yeah. And probably this also mentioned here. So we have designed a time-based key value data structure that can store multiple values of a different timestamp and retrieve the key values and obtain timestamp. Stored key with the value and the given timestamp. Return value such set was called previously. Yeah, so this one actually that I didn't understand actually means that every time set would be called with new timestamp, not the previous one. Okay. Yeah, but nice, we solved it, and see you next time then. Bye.